Module 16, T distribution and tests of significance based on T distribution. Section 2, independent T test. So as you know, there are two kinds of groups. One is called independent group. For example, marks obtained by a group of people and marks obtained by another group of people. For example, girls and boys. These are independent groups. Or disease incidents at one location and another location. Or the temperature at one location. See, these are all totally independent. While the second type of group is called paired groups, where you're measuring before and after some treatment has been done. So measuring the same value in the same patient or same plant or same microbe before and after. So these are basically match reading, So that is called the paired measurement. So independent and paired. So basically if you are doing some test, for example, to compare two groups or two group means, you will have to use different kinds of tests on these different kinds of the groups. So the student's T-test has a number of assumptions to make. The first assumption is that it has to be a random sample. The samples has to be random. If the cell, for example, if you're doing microbiology or cytology, if you're getting the cells in a clumped cell, of course that is not a random sample, So it has to be a homogeneous mix, not a heterogeneous mix. So then again, if you're doing an epidemiological study, then simply going to a nearby hospital and thinking that it's a random sample, that is influencing subconsciously all these decisions that you're making. So the sampling has to be totally random. So there are a lot of randomization of the sampling methods are available that you can use it. So observations have to be independent. So it should never be dependent observation. For example, the twins, if you're making both the twins are involved in your study, of course these are dependent, homozygous twins especially. And if you're taking a reading from your left eye and right eye, again there is a dependency in it. So observations have to be independent. The data has to be accurate. Of course, if you are working with the fabricated data, you will not get a good result. Garbage in, garbage out. That is a basic funda of the statistics. If you put the garbage for analysis, whatever the robust statistical measurement like Bayesian inference or a non-linear regression you do, nothing is going to come out. The come out is also going to be garbage. So these three assumptions are almost universally followed, not just for the T-test, but also for the F-test or ANOVA, or also for a regression or correlation, any kind of test. These three are very important: random sample, independent observation, and accurate data. Now coming forth, for the T distribution, the T-test is a parametric test. So it makes some guesses about the population from which the sample comes from. So population with approximate Gaussian distribution. So the population has to be normally distributed. So if the distribution is not normal, then the T-test is not appropriate. Fifth assumption for the T-test is that the variance or the standard deviation of the two groups are nearly equal. There is no significant difference in the variation of two groups that we are considering. And this one is known as principle of homoscedasticity. So equality of variance is a must for doing the T-test, but we will soon come to it later. But sample size between the two groups need not be equal. So one group can have a slightly lesser sample size while the other group has got slightly more sample size. No problem, you can still do the T-test. But if the variants are totally wrong, totally different, then probably this T-test is not a good answer for it. But little bit of variance differences are tolerated. Coming to the hypothesis, of course, in any statistical test, you first have to define your null hypothesis and alternative hypothesis. Here, the hypothesis for the comparison of means of the two independent groups are H0, that is null hypothesis is that mu1 is equal to mu2, that is mean of the group number 1 is equal to the mean of the group number 2. So there is no difference in the means of the two groups. While alternative hypothesis is that the mean of group number 1 is not equal to mean of the group number 2. That means differences in the mean of these two groups is not 0. that is the two hypotheses. Now let us consider a very simple example here, that is basically the old rat and the new rat. Some measurement has been done. I'm not going to the peculiarities of this study, or I have linked up the study in the course, the further readings. If you're interested, please look up that paper. So we have got old rats and then the new rat, the two groups which are totally independent. So how do you compare the means? So if you look at that, the means of these two groups are different. Standard deviation is also different. N is also different. Then how do you calculate it? First of all, I suggest you, before even going for the t-test, you just plot their 95% CI and see is there any overlap or not. So if you plot this 95% CI almost touching, but of course there is no overlap. So instantaneously you can conclude that the differences between the group means are significant. If they are overlapping, you cannot conclude that the differences are not significant. That is a problem with this confidence interval based approach. But still, in this case, it is not overlapping, so you can always say the p-value must be lesser than 0.05 and the results are significant. So you can compare the means of the two independent variables. Before the t-test, check if this distribution, so to know that one of the assumptions of the t-test is that the population has to follow the Gaussian distribution from which our samples came from. So you can test normality of the distribution by doing a K2 omnibus normality test that we have learned that in module number 10. So if it's normally distributed, proceed to independent t-test, or you can do an f-test prior hand. So in earlier textbooks of the statistics, everybody recommend you to do an f-test, to see the variances are equal or unequal. And there are two kinds of t-test assuming equal variance and t-test assuming unequal variance. Of course, these two variants are still available in the Microsoft Excel. But nowadays, statisticians say that f-test assuming unequal variances are not really a good t-test. So nobody should go with that t-test. So virtually f-test itself is of no meaning. You can directly go for a t-test. So if not normally distributed, what will happen? If the K2 normality test, omnibus K2 test returns that it is not normal, then what are the options for you? So you can go with non-parametric, well, that is the last stage. First you go with the parametric method, or you can avoid the normality test and try to look at that histogram. And if it's really not normal only, you have to go for non-parametric method, because the power, statistical power is far lesser than that of the parametric methods. Some of the non-parametric methods include Mann-Whitney U-test or Wilcoxon signed rank test. Of course, these are available in GraphPad Prism, but not in Microsoft Excel. That is the problem. F-test is, it measures the equality of variance or homoscedasticity. That means identical variance across the two groups. If you're comparing group number A and with B, so the variance of these two groups are equal or unequal. That is what the F-test compares. So F stands for Fisher, one of the founding fathers of the statistics. He designed this test, as well as the same Fisher F, the same alphabet is used for another distribution called F distribution. We are going to learn that in the next module. That is also because of the Fisher. So F test, what are the hypotheses in F test? So the null hypothesis, or H0, is that variance of group number 1 is equal to the variance of the group number 2. While the alternative hypothesis is that variance are not equal. So these two are the hypotheses of the F test. To do the F test, first you have to calculate the F ratio. And what is this F ratio? F ratio is very simple. That is the standard deviation of the group number 1 divided by standard deviation of the group number 2 squared. So all you have to do is take up the standard deviations of each group, and you actually divide it and then square it. And that is called F ratio. So where is standard deviation, where the standard deviation of group 1 and group 2, the standard deviation of the group 2, which I just explained to you. So now you can see this table, and you can simply calculate the standard deviations of the two groups, and then you can perform an F test. Let's do this in the whiteboard. So let us do this F test. So what is done in this F test? So first of all, let us define the null hypothesis as well as alternate hypothesis. So the null hypothesis, that is H0 is equal to, that is V1 is equal to V2, that is variance of group number 1 is equal to variance of group number 2 is the null hypothesis. What is our alternative hypothesis? That is variance of group 1 is not equal to variance of group number 2. This is our the hypothesis. For the F test to calculate, we need to have an F ratio, that is the F ratio is a requisite. So we know that standard deviation is standard deviation for the first group S1 is equal to 16.09, while N1 is equal to 9, and for the second group standard deviation S2 is equal to 10.36, while its N is equal to 8. So now let us calculate the F ratio, that is F ratio needs to be calculated from given these things. So F ratio is very simple, it is basically S1 divided by S2 squared. So that means that it is 16.09, that is our S1, divided by it is 10.36, that is our S2, and you have to square it. So basically that means that it is 1.553 squared. So the answer here is, it is basically 2.41. So this is our F ratio, 2.41. So our next step is that we have to find the F critical from the F table. So to look up the F table, we need to know the DF numerator and DF denominator. So DF numerator is basically 9 minus 1, and 1 minus 1 is DFN, while N2 minus N is denominator. So in this case, N1 minus 1 is 9 minus 1 is equal to 8 is the numerator, while denominator it is basically 8 minus 1 is equal to 7. So given these two at significance level of 0.05, so the F critical from the table, you can look up this value from the table. So F critical is equal to F critical is equal to 3.725. So which is larger now, F critical from the table or the obtained critical value is larger? So the table value is larger, that means that the inference is that P must be larger than 0.05, that means not significant, NS. So non-significant result is what we got. So P is larger than 0.05. So that means that the null hypothesis stands true. So that means that variance are almost same. So the principle called homoscedasticity is fine with this sample. So as I told you, as a table value, that is critical F is 3.72, which is higher than our obtained F ratio, that is 2.41. The table score is higher. So you can say that P value must be higher than 0.05, and you can conclude that results are not significant. What does that mean? Results are not significant means our groups the differences in variations are not significantly deviating from the randomness. So that means that they both have almost equal variances. So it's just fine to go with the normality test, And by the way, in any of these tests using the standard probability distribution tables, all you have to do is that whether the table value is lesser than the obtained value or greater than the obtained value. So if the table value is higher than the value that we have, like in this case, then your conclusion is that P value must be higher than the significance level, that is 0.05. If the table value is lesser than the value that we found, then P value must be lesser than 0.05 and results are significant. That is very straightforward. You can also do the same calculation on a more accurate method using this URL that I already linked up in your the quadrant for further studies, further resources. It calculates the exact P value of the F test. So for our earlier example, the p-value is, exact p-value is 0.3631, which is of course indeed much higher than 0.05. So the variances are not significantly different. That is the conclusion of it. Now let us do the t-test. How does this t-test work? So it's similar to the f-test. T-test also need a t-ratio. First we have to calculate the t-ratio, then we will go with the t-test. So one option is to calculate the t-ratio first, or the other option is to calculate the standard error of the difference first. So let us first go with an option called standard error of the differences. So first it calculates the standard error of the difference between the two group means. So SC differences between the group means. We know the group mean 1 how much, mean 2 how much. So just take difference, subtract of these two values. So that is the difference in the group means. Now how will you calculate the standard error of those differences? So to calculate that one, the formula used is, you can see that it's actually the square root of s square divided by m1 plus s square divided by m2, where standard deviation, s is standard deviation while m is a sample mean. So standard deviation square divided by respective sample means. Respective standard deviation square divided by respective sample means. You add it and take the square root to get. Let us do this on the whiteboard. So before doing a t-test, let us first calculate the standard error of the differences, SE differences. So standard error of the difference between two group means is, the formula is S1 square divided by N1 plus S2 square divided by N2 square root. So this is a formula to be used to calculate the standard error of the difference between the two group means. So what we know, let us put up here what we know is that S1 is equal to 16.09 while N1 is equal to 9. For the second group, S2 is equal to 10.36 while N2 is equal to 8. So just plug in to this equation, let us solve it. So that means that 16.09 squared, that is basically S1, divided by 9, that is N1, plus 10.36 squared divided by 8, all within square root. So that means that, well, let us simplify it, it's going to be square root 28.765 plus 13.416. So it's equal to square root 42.1815. So this is equal to 6.4947. So this value is the standard error of the difference between two sample means. So standard error of the difference is now known. So whenever you calculate the standard error of the difference between the two means, so it's always better to also calculate the confidence interval. From this value, it's very easy to calculate confidence, the 95% confidence interval. Given that the t, we have to know that we have to look up the t. So just multiply this value with the t to get the confidence interval, 95% confidence interval. So let us write it here, 95% CI of difference between two means is equal to standard error of the difference multiplied by T star. So the T star is basically the constant from the T distribution. So to know that, all we have to do is this n to get the degree of freedom. So the degree of freedom is basically, we have got two values here, n1, there are two groups here. The first group is 9 while second group is 2. So the total degree of freedom is basically n1 minus 1 plus n2 minus 1. So this is the overall degree of freedom. So the total degree of freedom is equal to n1 minus 1 is basically 8 plus n2 minus 1 is 7. So that is equal to 15. So if you look at 15 is the degree of freedom, and given the confidence level, that means alpha is 0.05, then you will find that the T star or the constant T from the student T distribution is equal to 2.1314. So this is the T value from the table that we are going to use this one for the calculation of 95% CI. So let us plug this one into this equation. So SC differences we already calculated, that is 6.4947, and T star is 2.1314. So just plugging into these two things together, that is equal to 6.49 multiplied by the T star, that is 2.1314. So that is equal to 21.48. So 21.48 is not the confidence interval, but this is only the width. So it is basically the width of the confidence interval is 21.48. So now, by the way, what is actually the mean? So we calculate the SC for the difference between two group means. So confidence interval of the difference between the two two group means is that. So basically, what is the difference between two group means? So the group means one is 53.71 and second group mean is 30.17. So these two things minus 30.17. So these are the two group means, so that is equal to 23.55. So this width has to be based on difference between the two group means. So 23.55 plus 21.48 and 23.55 minus 21.48, this is exactly our confidence interval. So 23.55 plus or minus 21.48. So this is what our 95% confidence interval. So 23.55 plus and minus. So let us calculate minus first. So if you 23.55, this 23.55 minus 21.48 is equal to 2.07, then plus 23.55 plus 21.48 is equal to 45.03. So we can also put 2. So 2.07 to 45.03, this is the 95% confidence interval. Now how do you interpret it? Because this confidence interval, 95% confidence interval, is based on this value. The value is basically the this one, 53.71 minus 30.17, that is basically this value, 23.55. This width is based on this value. So this value is the difference between two group means. So the interpretation is very simple. The null hypothesis is that there is no difference. That means null hypothesis means 0. So does this range include the 0 or not? No, because both are positive, 0 is not included. To include the 0, one value has to be negative and one value has to be positive. So there is no null hypothesis here. So therefore the conclusion is that the p value will be will be lesser than, not greater than, but it is basically lesser than. P value is going to be the lesser than 0.05, and the difference between the group means are significant. So it is basically significant S you can put. So this is the summary of this to calculate 95% CI of the difference between two group means. So width of the confidence interval depends on lots of factors, as I have already explained. One is the variability. Low standard deviation, if the standard deviation is very low, then the width is going to be lower as well. So if the standard deviation is very high, variability is high, then it will be a wider confidence interval is what you can expect it. So sample size also, the large sample size will bring the range much lesser. The confidence interval will be very narrow if the sample size is very high. Degree of confidence, so confidence level, narrower confidence would lead to a narrower CI. If you want high precision, high confidence, then it will be a wider CI, that what you can expect it. So now let us do the t-test using these parameters on the blackboard. So now let us perform the t-test. So to perform the t-test, it's fairly simple. So the t, we have to calculate the t ratio, that is only thing that we have to do it in t-test. So the t ratio or t is equal to m1 minus m2 divided by standard error of the difference. Remember, this is not SEM, it is the difference between the two group means. So the group mean of the first group, mean of the second group, subtract and divide by the standard error of the difference. This we have already calculated the standard error of the difference. So let us see what we know till now. So the first is M1 or the mean of the group 1 is equal to 53.71. Mean of group 2 is equal to 30.17, and we also know that SC difference. So SCD is equal to SC diff, we already calculated, that is equal to 6.49. So we all need to do is to plug into this equation. So that is equal to 53.71 minus 30.17 divided by 6.49. So this numerator is equal to 23.55. This is the absolute difference between the two group means. We have already calculated this one to calculate the 95% CI in the last the whiteboard. So 23.55 divided by 6.49, so is equal to 3.63. So this is the obtained t ratio of our t-test. So this is the most important parameter now. So now that we just have to look up the t critical from the t students t table, given that what is the t critical, given that alpha is 0.05 while degree of freedom, we have already calculated degree of freedom in the last whiteboard. So degree of freedom is basically 15, because this is basically n1 minus 1 plus n2 minus 1. This is how we calculated this 15. So degree of freedom is 15, and with this one we can calculate, we can look up the t distribution table to find what is the t critical. So if you look up, you can see that the t critical is equal to 2.131. So now the question is that is this value higher than this or lower than the obtained t score? So of course this is lesser than, the table value is lesser than what we got from our data. So that means that therefore p is less than 0.05 and the result is significant. So this is the summary of the t-test, how to perform using hand. It's actually quite simple, and if you perform, there are multiple methods for performing t-test using pen and paper, but this method has an advantage because if you know the standard error of the difference, you can also calculate the confidence interval just by multiplying this with the t. So that t is that you can actually look up in the table to find the confidence interval. So this method is preferred because we can also calculate the confidence interval. Even before doing the t-test, it's always recommended to do confidence interval as well. So we have seen the table value is less than the calculated value. So p has to be less than 0.05 and the difference is statistically significant. So the exact p-value calculated by the software is 0.0030, which is indeed less than 0.05. In case the calculated t ratio is negative, no problem. Take the absolute value of this result. The sign indicates just the directionality of the effect. So t-test can also be done in Microsoft Excel and the GraphPad Prism. We will be explaining that in more length in module number 18. So one guy called Moser and Strauss in 1993, he concluded that the modified t-test that accounts for unequal variances should never be used because the results will be misleading. So that paper still stand. So that my recommendation to you is that never go with the Excel's option to use that kind of test, unequal, assuming the unequal variance. That is not the right way. So if the test returns a low p-value or significant or unequal variance, perhaps the best option is that, the f-test returns a low p-value. So ideally f-test should return a high p-value. If the f-test returns a low p-value, perhaps the best option is, don't consider that, no problem, just go assume that it is actually variances are roughly equal and go ahead with the t-test. So that means that you really don't need to do the f-test anymore. So what is the point of doing that? If the f-test says that if it is unequal, still you have no other choice. You have to go with the normal t-test. So there is no point in doing the f-test prior hand. So even t-test is not necessary. As I told you, just drawing the confidence interval of the two means itself will tell you an answer, whether is it actually significantly different or not. So why do you want to go for the t-test? You are essentially doing the same thing. But if you really want to get the exact probability, then the t-test using the table alone will not suffice. You have to do this t-test in a computer, so that can calculate the exact probability of the t ratio. So in summary, the independent t-test is used to compare means of the two independent groups. Two assumptions of the t-tests are, the samples came from population that follows roughly normal distribution, and homoscedasticity, that means both the groups have got more or less equal variance. While conventionally f-test is done before t-test, statisticians suggest that modified t-test that allows for unequal variances should not be used. So virtually no point in going for an f-test. Hope you liked it. See you soon.